Welcome students, we are starting our study on mathematical reasoning. And foremost, you need to know what is a statement. This is also referred to as a proposition. Now, a statement is a sentence which is either true or false, but it cannot be both. So this is the actual definition for a statement or proposition. Now, a statement can be represented with lowercase p, q, r, etc. So this is how we represent a statement. Now, examples of statements can be as follows. The first one is 6 is greater than 2. Number 2, hard work brings success. Number 3, speed is dangerous. Okay, so three examples I've given you. 6 is greater than 2. Yes, it is. Hard work brings success. Yes, this is true. This is true. Speed is dangerous. This is also true. So all of these things are true. And Moscow, you can just take this. Moscow is in India. Number 5, New Delhi is in US. Number 6, if you sleep more, you cannot achieve. Okay, Moscow is in India. True or false? False. New Delhi is in US. True or false? False. If you sleep more, you cannot achieve. Of course, this is true. Because sleep and laziness, they go hand in hand. Say you have a target, right? And your target is to crack a very important competitive examination. Say IIT. And if you are sleeping for 8 to 10 hours a day, do you think it's possible to crack the exam? So, of course, sleep is important, but if you sleep more, you cannot achieve. So that is a truth statement. So I've given you some illustrations, so we will go further. Next, you will have to know what is paradox. Statement which is both true and false at the same time. Say the first example is war is peace. What can you make out of this? Number 2, less is more. What can you make out of it? Number 3, 1 plus 2 plus 3 plus 4 plus etc. plus infinity is equal to negative 1 over 12. What can you make out of this? Say for example, you see this, the left side. it is going up to infinity, and on the right side it is a quantity, it is a numeric value. Is it possible for us to represent infinity as a numeric quantity? No, but still we are able to represent. So that is why we call this a paradox. Next, you got to know what is an open statement. A statement which contains variables. Now, the outcome of the statement, whether it being true or false, would largely depend on the value that the variables take. Say for example p. I'm going to take p is equal to, say x is a natural number. This is the example for open statement. So p is equal to, x is a natural number. Now if I were to take x is equal to 21, then p is true because 21 is a natural number. But if I were to take x is equal to negative 21, then p is false because x is equal to negative 21 is not a natural number. So the outcome of the statement largely depends on the value that the variable take. So we'll move on to the next one. Now next we will have to know what is a simple statement. So simple statement can be defined as follows. A statement that is direct and contains no modifiers. Now, what is the meaning of modifier? Modifier is nothing but it can be a clause or a phrase or a word which is actually used to provide extra meaning to the sentence. So we don't have such entities in a simple statement. So the best way to define is a statement that is direct and contains no modifiers. Example, the sun rises in the east. Milk is white. Water is good. So these are all some of the illustrations for simple statement. And the added benefit of simple statement is they are easy to conclude. So you can easily say if it is true or false. So in this case, sun rises in the east, it's true. Milk is white, it's true. Water is good, it's true. It's simple, right? So that is how we define a simple statement. Next is what is called as compound statements. Now, compound statements, these are statements that are made up of two or more simple statements. Right, so they are called as compound statements. Now, another word for simple statement is also called as atomic statements. This is another word for simple statements. Now, atomic, as I mentioned to you, is actually used to represent simple statements. Now, for compound statements, another word for compound statements is complex statements. You can either use the term complex statements or compound statements. So how are they made? They are made by using two or more simple statements. Say for example, if you drive at 90 miles per hour, then you will be fined. If you drive at 90 miles per hour, then you will be fined. This is a compound statement because it uses, of course, we have not studied this. When we study implications, I will tell you how to use if and then. So if there is a statement here, then this is what is the consequences. Then you will be fined. Another example, let me give you this. Even numbers are divisible by 2 and 2 is an even number. So even numbers are divisible by 2. This is a simple statement. 2 is an even number. This is also a simple statement. Now and is the connective that is connecting two simple statements. So these are two different examples, but they are still compound statements. So having given you all this, let's move on. Now next we will have to know about the connectives that are available. Now what exactly is a connective? It is an operator that is used to join two or more simple statements to form compound statements. I'm giving you an illustration just a little bit earlier. We will look into more illustrations. Now, some of the connectives are in fact the connectives that are included for your syllabus is as follows. So these are the basic connectives that we will be using. The first one that you will have to know is the AND operator. The symbol form is like this. It's like a wedge, and it is, as I mentioned to you, all of these connectives are used to make compound statements, and we refer to this as conjunction. C-O-N-J-U-N-C-T-I-O-N. So this is the first one. The second one is the OR operator. We symbolically represent this in this fashion, and we create disjunction statements. So number 3 is called as the if then operator. So the representation is as follows, and we call it as conditional statement. We create conditional statements using if then. And then the fourth one is called as biconditional. It's if and only if. So the representation is as follows, and as I mentioned to you, we use it to create biconditional statements. Right, so these are the 4 all important connectives that we will have to know. Okay, so we will do questions related to these connectives so that we get a better understanding. This is the truth table for AND. I will give you a trick so that you will be in a better position to approach these questions. So we got P and Q, so I'm going to take T, T, F, F, true, true, false, false, and for Q I'm going to take true, false, and true and false. Now we are apt to obtain P and Q. Now what happens when you have true and true? Now remember, T is taken to be as 1 and F is taken to be as 0. Now this operator which you see here is considered as a product operation. So in other words, when I am telling you true and true, what am I asking you? What happens when you multiply 1 with 1? What would you get? You're going to get 1. In other words, you are going to be getting T, right? So true and true is going to be true. Use this concept, use this particular trick which I've just explained to you. Consider this as a product and T to be as 1 and F to be as 0. So 1 into 0, in this case 1 into 0 will give you what? 0. So that's going to be false. Now 0 into 1, that's going to be 0. That's going to be false again. False into false. In other words, 0 into 0 is going to be 0. So that's going to be false. So this is the truth table for the AND connective or the AND operator. And you will never go wrong if you follow my technique. There is no chance of you becoming or going wrong if you were to follow the trick or the technique which I just mentioned to you. Let's move on. Now let us study the truth table for the OR operator. Now I'm going to use the same truth table which I have just shown you. So let me draw that. So we've got P, Q and P or Q. This is T, T, F, F, T, F, T, F. Now we call this as disjunction, right? This operator is called as disjunction, and we also refer it to as the OR operator. So true or true. So in this case, the OR operator is treated as addition operator, and as I mentioned to you, T is taken to be as 1 and F is taken to be as 0. So 1 added with 1, the outcome will be 1. Of course, this is in the understanding sense, right? You know, you may be prompted to say it's 2. No, we are looking for the understanding what happens when true is added with true, right? And the other illustrations that are being provided here is like a side note that is guiding you to get the right answer. I would like to make that point clear. So in this case, 1 added with 1, true or true will give you true. So 1 added with false, true or false is going to be true. So 1 added with 0 is going to be 1. So it's going to be true there. So 0 added with 1, that's going to be 1. In this case, it's going to be false or true is going to be true. False or false, 0 added with 0 is going to be 0. So that's going to be false. So this is the outcome. Then we will have to know the truth table for the NOT operator. Now NOT is also called as negation. Have that in mind. So if you are going to be having a truth table for P with 2 values being given there, now what is the NOT operator represented as? Say this is the way we represent a tilde and P. This is also called as the negation of P. Now suppose you have T and F, then the NOT of P is going to be NOT of T. So what would be the NOT of T? That's going to be F, right? And what's going to be the NOT of F? that's going to be T. In other words, we will also sometimes encounter people saying, what is the negation of P? So in this case, its representation is tilde P, and the negation of T is false and the negation of false is true. Okay, we'll move on. Now, next I'm going to teach you the truth table for if then, and it is represented like this: if P then Q. It's also said P conditional Q. So how do we construct the truth table? Let me give you a tip for that. Let me design the table. We got P and Q, and this is P conditional Q. So the values are T, T, F, F, T, F, T, F. Now remember, if you have something like this, T going to F, the outcome will always be F. This is all that you need to get the truth table. The rest of the cases will result in true. So in this case, true P conditional Q. So T conditional T. If T, then T is going to be T. T going to F. T going to F. The outcome is going to be F. F and T, it doesn't matter. All other things is going to be true. So this is the trick that you got to know. If you know this, everything else would be simple. So this is the truth table for if then. Now the next thing we need to know is the truth table for if and only if. How are you going to handle this? So this is called a biconditional, right? Now I'm going to give you a trick for this also. So let me just draw the table first. So we got P and Q, and this is going to be biconditional. This is Q, this is P. Now this is T, T, F and F. This is T, F, T, F. Okay, now here is a trick. Let me draw another table for your understanding. Okay, so this is my P, Q, P conditional Q, Q conditional P, and the biconditional is actually P conditional Q conjunction Q conditional P. So let me write that down here. P conditional Q conjunction Q conditional P. This is what is called a biconditional statement. So biconditional statement is represented in this fashion: P biconditional Q, which is nothing but P conditional Q in conjunction with Q conditional P. Now before I could put in the information here, let me show you how exactly the values are obtained for biconditional statements. So this is going to be T, T, F and F, T, F, TF. P conditional Q. I already told you, if you get something like this, T going on to F, then the outcome is going to be F. So look for that. T going on to F, the outcome is F. The rest of them is going to be T. Now it's Q conditional P. In other words, P is not the leading column. In this case, P was the leading column. So in this case, Q conditional P, Q is the leading column. So you look for T going to F for Q conditional P. So T going to F, so you got a T going on to F. So this is going to be F. The rest of the cases would give me T. Now this is nothing but P by conditional Q is nothing but P conditional Q in conjunction with Q conditional P. So there is a conjunction between T and T. So as I mentioned to you, we treat conjunction as the product operation, and we take T as 1 and F as 0. So T conjunction T, it's T. This is 0 multiplied with 1. That's going to be 0. 1 multiplied with 0, that's going to be 0. 1 multiplied with 1, that's going to be 1. So that's going to be T. So this is what would be featured here. This is T, F, F, F. So this is the easiest way to remember the truth table for biconditional statements. Students, we will now look into the properties. This is very important. Now, I've already mentioned to you the two connectives which we will be looking at. One will be disjunction, the other will be conjunction. Now, disjunction is actually treated as a union, and conjunction is treated as an intersection. So have this in mind. So this is a side note, or I would say a tip for you. So having given you that tip, let's head on to properties. Suppose you have P disjunction of Q disjunction R. This is same as obtaining P disjunction Q disjunction R. This law is associative law. Now this is for disjunction. Now if I were to give this for conjunction, then this is going to be as follows. P conjunction of Q conjunction R is same as P conjunction of Q conjunction of R. The next law is commutative law. Commutative law or commutative property. Now for disjunction, P disjunction Q is same as Q disjunction P, and P conjunction Q is same as Q conjunction P. Now let's move to the other law. Next is the distributive property. Number 1, P disjunction of Q conjunction R is equal to P disjunction Q, and in the middle there is going to be a conjunction, and then P disjunction R. P disjunction R. Right? Now property number 2. P conjunction of Q disjunction R is equal to P conjunction Q. You have a disjunction, and then P conjunction R. Right? That's a distributive property. Now next is identity. Now there is an important concept which we have come across, tautology and contradiction. Tautology is associated with the universal set, and contradiction is associated with the empty set. So if you have P disjunction tautology, what happens when you have P union universal set? you will get a tautology. That's universal set. Property number 2. What would happen if you have P conjunction T? In this case, it's P intersection T. So what do you get? You get P. Because this is the smallest set, this is the largest set. Now next is, what would happen if you have P disjunction empty set? So which is the smallest set here? This, but this is union. So you get the largest set together. That's going to be P. Now to the fourth one, P conjunction C. This is an empty set. You are intersecting it with P. So what do you get? You get C. I hope you are able to catch the gist of it. Let's move on. Next we are going to be looking at the complement laws. The first one is P disjunction of negation of P. What would this be? Now when we are talking about negation of P, this includes all those elements which are not in P. So this is actually P union P complement. So what happens when you perform this? P with its complement both being united together, you will get a tautology, you will get T. Number 2, what happens when you perform a conjunction with the negation of P? This is nothing but P intersecting with P complement. This is collection of all elements in P. This is collection of all elements which are not in P. Will that have an intersection? Intersection is going to be empty. So in this case is going to be a contradiction. This is number 3. What is the negation of a tautology? That's going to be a contradiction. And what is the negation of a contradiction? That's going to be tautology. So these are all straightforward laws. Now next comes De Morgan's laws. Very important. Now the first one is, you got a negation of P disjunction Q. You distribute the negation inside. So this is going to be negation of P. When negation hits the disjunction, it becomes conjunction. And you have a negation of Q. Law number 2. Negation of P. This is going to be a conjunction, right? We took the disjunction here. This is conjunction. So negation is distributed. So it's going to be negation of P. Negation its conjunction, it will become disjunction. So it's going to be negation of Q. So this is a very important law. Now we are going to prove 2 important laws. P conditional Q is same as negation of P disjunction Q. And we will prove this, and we will also prove negation of P conditional Q is same as P conjunction negation of Q. I'm going to use truth table to show the validity of these laws. So first let me show this law. Now let me draw the table. I hope this would be sufficient enough. So I need to have a P and then a Q and then negation of P, negation of Q, and then P conditional Q, and finally the disjunction. So let me draw the heading. So this is my P, my Q. Let me take this as negation of P, negation of Q, and P conditional Q, and then negation of P disjunction with Q. We don't actually need negation of Q, but I have taken negation of Q. It's alright. So I'm taking the truth values as T, T, F, F, T, F, T, F. Negation of P, this is going to be F, this is going to be F, this is going to be T, this is actually F here, this is going to be T. I've just taken it, so I just want to complete the negation of Q. That's F, T, F, T. Now remember, P conditional Q, whenever you have T going to F, the outcome is going to be F. So look for T going to F. T going to F is over here, outcome is going to be F. The rest of the quantities is going to be T, T, T. Now this is going to be negation of P in disjunction with Q. Negation of P disjunction with Q. So this distinction is treated as addition operator. Have that in mind. So that would be simple to obtain. So negation of P is here. This with Q, disjunction with Q. So 0 added with 1 will give me 1. 0 added with 0 will give me 0. 1 added with 1 will give me 1, and 1 added with 1 will give me 1, right? Now check this, T, T, F, F, T, T, F, F. So hence P going to Q is equal to negation of P disjunction Q is verified. Now next verification is this. We have to show that negation of this, negation of P conditional Q is equal to P disjunction of negation of Q. Okay, so what I will do is I will just stretch the table. If I would not have placed this, it would have been really good. The outcome would be crisper and neat. Anyway, there's always going to be next time in getting things right. So I need to obtain negation of P conditional Q. Let me place the negation of P conditional Q, and then I have to compare it with P conjunction of negation of Q. Initially I wondered why did I place this negation of Q. Now it comes in handy, right? So nothing in life is wasted. Okay, so let me just perform this. This is nothing but negation of P conditional Q. So where is P conditional Q? Over here. Negation of T is F, negation of F is T, negation of T is F, negation of T is F. Fine. Now P conjunction with negation of Q. Where is P? P is in conjunction with the negation of Q. So as I mentioned to you, we take this conjunction as multiplication operator. So 1 into 0 is 0. So that's going to be false, F. And then 1 into 1, T, that's 1. 0 into 0, 0. And 0 into 1, 0. So that's going to be F. Now F, F, T, T, F, 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 F. Hence, negation of P conditional Q is equal to P conjunction with negation of Q is verified, right? So that is a beautiful verification. Students, let's do this beautiful question. The contrapositive of the statement. So we are asked to obtain the contrapositive statement. for the following given statement. So let me write that, the contrapositive of the statement. If you will work, you will earn money. So this is very philosophical and is also meaningful. So that's why logic is the favorite subject of the philosophers. It has got a lot of important meaning in this. So if you will work, then you will earn money. Now we are expected to obtain the contrapositive. Now contrapositive statement, say for example, this is represented as P conditional Q, right? To obtain the contrapositive statement, it has to be negation of Q conditional with negation of P. So this is the exact equivalent, or in other words, this is the contrapositive for P conditional Q. So the choices are given. Let me write the choices first. A, if you will not earn money, you will not work. Number B, you will earn money if you will not work. C, if you will earn money, you will work. Number D, to earn money, you need to work. Okay, now negation. Negation means, say this is my P, this is my Q. Negation of Q means not has to be there, right? A not operator should be there. So we have to start with this. You will earn money. That means you will not earn money. That should be the starting. And where do you get you will not earn money? Clearly, there is only one place which you can clearly identify. You will not earn money. You will earn money if you will earn money to earn money. You see that? If you will not earn money, you will not work. This is a negation here, a negation here. So this is going to be the right solution, because you will earn money if you will not work. There is no negation here. Only negation is present here. If you will earn money, no negation here. No negation here. To earn money, you need to work. No negation. Of course, all of these have got a meaning and understanding, but we don't need meaning and understanding. Meaning and understanding alone is not sufficient for us to get the solution. We need logic. This logic has to be obtained, and this logic is only present in A. So A is the right solution. So we'll move on to the next question. Let's do another question, students. We are expected to find the contrapositive of the following statement. The statement is given as follows. If I reach the station in time, then I will catch the train. So we are expected to obtain the contrapositive of this statement. This is P and this is Q. The contrapositive of this is going to be negation of Q, conditional negation of P. So we will have to obtain this. So we have been given the following choices. Choice A is if I do not reach the station in time, then I will catch the train. So let me read out the following four choices. The first choice is, if I do not reach the station in time, then I will not catch the train. So in this case, we need to obtain the negation of Q. So the negation of Q will be, I will not catch the train. So it's going to be like this: if I will not catch the train, followed by the negation of this, then I will not, or then I do not reach the station in time. So if you were to observe the choices, clearly you can see that the first choice is stating as, if I do not reach the station in time. So it is not talking about the negation of Q. B states, if I do not reach the station in time. It's same thing. So B is not going to be the right choice. The C, if I will catch the train. So we are talking about negation. So where exactly will I will catch the train will fit in? No, right? So the right choice is going to be D. If I will not catch the train, then I do not reach the station in time. So the negation of Q is I will catch the train. So the negation of Q is going to be I will not catch the train. And similarly, P is if I reach the station in time. So the negation is I will not reach the station in time. So we need to follow it up in this fashion. I will not catch the train, then I do not reach the station in time. So the right choice is going to be choice D for this question. Let's try one more question. We've been given the following statement and we are expected to obtain the contrapositive of the statement. Let me write the statement. If a function f is differentiable at a, then it is also continuous at a. Now if I were to take f is differentiable as p and it is continuous at a as q, then we are expected to obtain the negation of q conditional negation of p. So the negation of p in this case is going to be the function is not continuous. So if you were to look at the choices, definitely a is not going to be the right one, because a states if a function f is continuous. We are not talking about the function being continuous. We are looking at the negation of q. So in this case it has to start, if a function is not continuous at a, then it is not differentiable. So we need to have a negation, not here and not here. So clearly you can see that the right choice is, of course D is not going to be the right one, because D starts with saying if a function f is continuous. So A and D is ruled out. Now if you were to look at B, it says if f is continuous at a, then it is not differentiable at a. So let me read that statement. If f is not continuous at a, then f is not differentiable at a. So B is going to be the right one. You know why? Because if you were to look at C, just read the statement. If f is not continuous at a, so the first part is correct, but subsequently the later off it states then f is differentiable. But we are not looking at the function being differentiable, we want the negation of the statement, right? So in this case C is also ruled out. So the only correct answer is B. Let's do another question. We expect to obtain the contrapositive for the following. Contrapositive of the statement. So the statement is given as follows: for an integer n, if n cubed negative 1 is even, then n is odd. Now the requirement is negation of Q, conditional negation of P. So if I were to take, you don't have to worry about the first statement, or I would say the first part of the statement. For an integer n, this is of no importance at all. So we can outrightly ignore this. What matters as is the sentence which is featuring after the if statement. So if n cube negative 1 is even, then n is odd. Now we are expected to obtain the negation of Q, conditional negation of P. What is the negation of odd? It is going to be even. So the negation of n cube negative 1, the P featuring part here, is given to be as even. So what's the negation of that quantity? Even is going to be odd. So the statement would be something of this fashion. If n is even, n cube negative 1 is odd. We are looking at that to be the contrapositive for this given statement. So examine B. Let me start with B. You can clearly see that for an integer n, okay, we ignore that, n cubed negative 1 is not even. So we don't have to start with this, right? We have to start from here. So B is ruled out. So C, for an integer n, if n is even, so if n is even, that's fine, then n cubed negative 1 is odd, but it states even. So C is also ruled out. Now D states if n is odd, it starts with n is odd, so D is also ruled out. So the only possibility is going to be A. So clearly we see that if n is even, then n cubed negative 1 is odd. So this is the right contrapositive for the given statement. Let's do another question, students. We are expected to obtain the contrapositive for the following statement of the following statement. The statement given as follows. If A is a subset of B and B is a subset of D, then A is a subset of C. So this is my Q, this is my P. Now we are expected to obtain negation of Q, conditional negation of P. This is what is required. Now clearly negation of Q is going to be A is not a subset of C. That's fine. But when it comes to negation of Q, negation of P, it is going to be, if I were to write this as negation of A subset of B and B subset of D. So if this is taken as P and this is taken as R, I'm breaking this entire statement. Instead of taking it as P, I'm splitting it as P and R. So we are actually looking at the negation of P conjunction R. So this is what is the subsequent follow-up. So negation of Q, conditional negation of P would be actually starting with the first part, A not a subset of C. Then we would have negation of P conjunction R. So what is this exactly? This is going to be negation of P. When I apply the negation for the connective conjunction, it will become disjunction followed by the negation of R. So this is what we've got. So negation of P, I have split the entire statement as A subset of B. This part is going to be my P. And negation of P means what? A is not a subset of B. This is disjunction. So it's going to be followed by R. And the negation of R, B is not a subset of D. Right? So this is going to be the output. So if I were to write the output, it's going to be if A is not a subset of C, then A is not a subset of B, or B is not a subset of D. So this is what is going to be our final solution. Now if you were to look into the choices, clearly A is not the right choice, B is not the right choice, C is not the right choice, and D is the only right choice, that we can clearly pick it up. You can clearly see that A is not a subset of C, then A is not a subset of B, or B is not a subset of D. So that is quite a sum, and we'll move on to the next question. Let's do this question. We are expected to obtain the contrapositive for the following statement. And the statement is given as follows: if you are born in India, then you are a citizen of India. So we are to obtain the contrapositive. That would mean we would have to obtain the negation of Q, conditional negation of P. If I were to take this as P and this part as Q, so the outcome is going to be the negation of Q. You are not, if you are not, let me give you the outcome. If you are not a citizen of India, then you are not born in India. So the best way to obtain the right choice is to first conclude the outcome. Then you can go and pick up the choices. Say, you can clearly see that choice A, if you are not a citizen of India, then you are not born in India. See, clearly you can see that choice A is going to be the right one. Of course, choice B and C and D are not the right one, so A is going to be the right solution for this question. Let's do another question, students. We are expected to obtain the contrapositive of the following statement. The statement given as follows: if two numbers are not equal, then their squares are not equal. So if I were to take this statement as P and this statement as Q, we expect to obtain the negation of Q, conditional negation of P. Now we start with the Q part. Then their squares are not equal. So if their squares are equal, that would be the outcome, right? Because not is already there, so the negation of this statement is going to be not would be removed. So the outcome is going to be if the squares of two numbers are equal. Two numbers are equal. So if the squares are equal, then the two numbers are equal. So not have to be removed. Then the two numbers are equal. So this is the outcome for negation of Q, conditional negation of P. So clearly if you were to go and check the choices, you can see that A clearly states if the squares of two numbers are not equal. So we don't need that. So A is gone. And check for B. If the squares of two numbers are equal, okay, the first part is fine. Then the numbers are not equal, it says. So B is also gone. C, if the squares of two numbers are equal, then the numbers are equal. Then the two numbers are equal. So clearly C is going to be the right choice. D is not the right choice. You can clearly see that also. So having given you this, let's move on. So students, now we will do property based questions. So first question is, which of the following is equivalent to the Boolean expression P and negation of Q? Now clearly I have given you the equivalent formula when we started logical expressions, and this equivalent formula is going to be, we are asked to find what is the equivalent for P and negation of Q. That's going to be negation of P conditional Q. So don't forget this formula. So clearly the only choice which we can see there is going to be choice D. So this is a simple question, and the only requirement is that you need to remember the properties. So the keyword is remember. And how are you going to remember? By constant practice. Let's do this question, student. We are expected to obtain the negation of the following statement. This is P disjunction R conditional Q disjunction R. Now let me take this as A and let me take this as B. So we are expected to obtain the negation of A conditional B. Now the negation of A conditional B is what? This is nothing but, just now we have a formula. The negation of P conditional Q is nothing but P and negation Q. So this is going to be A and negation of Q. Negation of Q is going to be negation of B here. Now my A, rewrite that. It's going to be P disjunction R, that's my A, with the conjunction followed by the negation of B. B is going to be Q, V, R. Now just distribute this negation. This is equal to P, V, R disjunction, I should say conjunction, followed by, I am just distributing the negation all across. So this is going to be negation of Q. Negation, when it hits disjunction, that would become conjunction, followed by the negation of R, right? Now we got the component like this with the conjunction being featured there. I already explained to you, we take conjunction as intersection. So A intersecting B is equal to B intersecting A, right? So by this property, negation of Q conjunction negation of R is same as negation of R conjunction negation of Q. So I would like to flip this and rewrite this as P disjunction R, you got that conjunction there, followed by negation of R conjunction negation of Q. This is what we have got. Now what I wish to do is, I would like to rewrite this by clubbing them together. So let me use this space here. So this is equal to P disjunction R followed by conjunction negation of R, parenthesis, right? I can group them like that, followed by a conjunction of negation of Q. Now this is actually a distributive property. Now let me just show that with some clarity. So this is what we have got. We have got P, V, R with conjunction of negation of R followed by conjunction of negation of Q. So this is what we have got. Now let me consider this alone for your understanding. So I can very well write this, because if I were to have a property, distributive property like this, say A intersecting of B union C, I can rewrite this as A intersecting B, right, with the union of A intersecting C. So this is exactly what I'm going to do. So we got, I'm going to rewrite this in this following fashion. So I'm going to start with negation of R followed by conjunction, and then we have got P disjunction R, right? So this is equal to, I can write this as negation of R conjunction P followed by disjunction, and then negation of R conjunction R, right? So this is taken care of with followed by the disjunction operator or connective, and then subsequently you are apt to distribute negation of R with R. So negation of R conjunction R. Now this is actually empty, right? Phi, we represent it as a formula, we take it as phi or C. So this is going to be empty set. So what are we having here? We are having here negation of R conjunction P union phi. That's not going to have any impact at all. So this is what we have got. Okay, now this is just one part, right? Because we have to, let me just show that to you. We have just considered this part, but to get the final answer, what we need to do, so this is going to be, this part is nothing but negation of R conjunction P followed by conjunction negation of Q. So if you were to write this, you can subsequently rewrite this in this following fashion, right? See, you have conjunction, conjunction. It can also be rewritten like this: P conjunction negation of Q followed by conjunction negation of R, which is nothing but choice A, right? So that is the solution for this question. Let's do this question, students. We've been given, consider the two statements. So it's represented as S1. So we've been given P conditional Q disjunction negation of Q conditional P is a tautology. Statement 2 is P conjunction negation of Q conjunction negation of P disjunction Q is a fallacy. Now we've been given a series of choices. Choice A, only S1 is true. Choice B, S1 and S2 are false. Choice C, S1 and S2 are true. Choice D, only S2 is true. Now what I wish to do is, I would like to start off by applying or validating the first statement. We've been given P conditional Q and we got a disjunction with the negation of Q conditional P. Now let me just consider this P conditional Q. Now P conditional Q is nothing but negation of P disjunction Q. This is the formula. So therefore we can rewrite P conditional Q disjunction negation of Q conditional P to be as, in place of this I'm going to substitute negation of P disjunction Q followed by disjunction of, now just I given you this particular formula, right? I am going to be applying the same formula over here. So this is going to be negation of negation Q disjunction P, right? So this is equal to negation of P disjunction Q disjunction, negation of negation Q is going to be giving me Q with the disjunction of P. Now what I wish to do, you can clearly see that you have a disjunction, disjunction, disjunction. So I can club these two together. So you got negation of P, disjunction, Q, disjunction Q. So we are treating this disjunction as union, followed by union with P. Now what is this? This is negation of P. Q union Q is going to be Q. So let me place that connective disjunction. As I mentioned to you, Q union Q is going to be Q, followed by union with P. Now I'm going to club these two together. So this is going to be negation of P union P union Q. Now what is negation of P union P? This is nothing but tautology, which we have already seen. It's a formula, we have already seen that. So this union Q, what happens to the universal set uniting with any other set? This is going to be resulting in a tautology, which in turn means a universal set. So clearly our S1 is true. Now we need to show that S2 is a fallacy, or it is not a fallacy, right? We need to ascertain that. So what I'm going to do is, this is what is given to be as S2. So I will construct the truth table. I will take P, Q, and then negation of P, negation of Q, and then P conjunction negation of P, and then this is actually negation of Q, right? And then followed by negation of P, disjunction Q, and then finally we are going to have P conjunction negation of Q. This is conjunction with negation of P, disjunction Q. So we got to see if it is a fallacy or not. So I'm going to use the truth table for a change. Okay, so you can actually get the outcome within a matter of a few minutes, but I wanted to ensure that a table is created, so that's why I'm taking my time in creating the table. You don't have to do that. So if you are fast, you can literally, since I'm making a presentation, I want it to be a little bit more better. So I will just cover this up and cover this up, okay. So let me take in the values for P. So T, T, F, F, Q, T, F, T, F, negation of P, T, F, T, F, F, T, F, T, negation of Q, T, F, F, T, T, F, F, T. Now we are looking at the conjunction of P with negation of Q. So as I already mentioned to you, we take T as 1 and F as 0, and this conjunction operator as product. That's the clue I've given. So this versus this, so 1 into 0 is going to give me 0. That's F, 1 into 1, T, F into F, F, F into T, F. Now this is going to be negation of P in conjunction with Q. I should say disjunction, it's not conjunction. We applied conjunction here, this is disjunction. So negation of P with conjunction in disjunction with Q. So as I mentioned to you, we take disjunction operator as plus. So let's see what outcome is going to be, this versus this. So 0 plus 1 is going to be 1, 0 plus 0 is 0, 1 plus 1 is 1, 1 plus 0 is going to be 1. So we have already got that. Now what we need to do, we need to perform the conjunction between this and this. So f with t, that's going to give me f. T with f, that's going to give me f. F, t, f, f, t, f. So what is this? This is nothing but contradiction, or we call it as a fallacy. So clearly, what is the implication? Clearly, both S1 and S2 are true. So that would mean the choice is going to be C. So this is the right choice for this particular question. Let's do this question, students. For any two statements, P and Q, the negation of the expression P V of negation of P conjunction with Q is what? We've been given the following choices A, B, C, D. Now before we could go on to make a decision on the choices, let us simplify this. So what I will do is I will first consider P disjunction of negation of P conjunction Q. Now we can distribute P disjunction, and that is going to be giving us P V negation of P followed by conjunction and then P V of Q. Now this is universal set. It's also called a tautology. So this is equal to, now you got a conjunction there, and as I mentioned to you, we are treating this as an intersection. So universal set intersection with any set would give us the set back. So this is what is obtained. Now we are expected to get the negation of the expression. So therefore let me draw this off. Negation of P VQ is equal to negation of P conjunction negation of Q. So if you were to look at the choice, the right choice for this question would be choice A. Let's do this question, students. We've been asked to find the Boolean expression the equivalent for this Boolean expression, negation of P V Q and then V negation of P conjunction Q is equivalent to what? And we've been given the following choices. Now whenever you've been given an expression of this nature, first try to simplify this. So let me just do that. Consider negation of P V Q followed by V of negation of P conjunction Q. Now if I were to distribute this negation, this is going to be equal to negation of P. This V would become intersection and followed by negation of Q, and we got a V of negation of P conjunction of Q. Now you got a negation of P, negation of P. You can take that negation of P out. Now if you were to take that out, you got this conjunction here. So what you can do is you can place that conjunction and open the parenthesis, and you can combine negation of Q with Q. So what have I done? I've just taken negation of P out. Then you got the connectives. You got the conjunction here and a conjunction here. So I'm placing the conjunction out. And I am connecting negation of Q with Q by means of the connective disjunction. But what is this? This is actually the distributive property expansion. That's exactly what it is. Now what happens when negation of Q unites with itself, or I should say with Q? That would give us a tautology. So this is going to be negation of P intersecting with tautology. Now what happens when you perform an intersection with the universal set? You get back the set which is actually performing, which is subjecting itself to an intersection with tautology. So in this case, this is going to be negation of P. So this is the solution, and in this case the right answer is going to be choice D. Right? Let's do this question, students. We are expected to obtain the negation of the following statement: negation of S V of negation of R intersection S. We are expected to pick one of the choices, and this is the completion of the question. This is, in fact, the negation of this is equivalent to. So that is the complete question. So what I would do is I would start off by consider negation of S, disjunction negation of R, this is R, conjunction S. So let us distribute negation of S with the connective disjunction throughout. So this is going to be negation of S, V negation of R. Then you got the conjunction followed by negation of S union S. So what is this? This is a tautology. This is universal set T, and there is a conjunction with negation of S V negation of R. So we are performing an intersection with the universal set, so that would mean we would get back the set. So this is going to be negation of S disjunction negation of R. Now we are expected to obtain the negation of this. So therefore negation of S V negation of R is equal to negation of negation S. When negation attacks the disjunction, it becomes conjunction, followed by negation of negation R. Negation of negation S is going to be S, followed by conjunction. Negation of negation R is going to be R. So the exact choice for this question is choice B. Let's do this question, students. We've been given the following question: find the negation of the statement root 5 is an integer or 5 is irrational. So we've got the following four choices: A, B, C, D. Now before we could try to zero in the choice by looking at them, it's better to first understand what is given, and then using our representation for the statements, we would be able to apply the property and directly get the solution. And then we will go back to the choices and see which of these choices are the best fit. So having mentioned that, let me just take this entire statement to be as P and this entire statement to be as Q. We are expected to obtain the negation of P, or is going to be disjunction Q. Now what is the negation of P disjunction Q? This is going to be negation of P When negation hits disjunction, it becomes conjunction followed by negation of Q. Now P is root 5 is an integer, so negation of P is going to be root 5 is not an integer. The or, in place of or you got the the intersection, right? So this is nothing but conjunction. So we represent conjunction as and. This is followed by the negation of Q. Q is actually 5 is irrational. So the negation of this is going to be 5 is not irrational. So this is the exact outcome for the requirement that is being asked here. So since we already know this to be this, or I should say we have obtained this to be the solution, if you were to go and look at the choice, clearly A says root 5 is not an integer or 5 is not an irrational. So definitely we need to get and. So A is not the answer. And C and D also is ruled out. The only possibility in this case is B, because B clearly states that root 5 is not an integer and 5 is not irrational. So the correct choice for this question is B. Let's do this question, students. We are expected to obtain the negation of the following statement. Find the negation of the statement. Negation of P conjunction P disjunction of Q, and we get the following choices A, B, C, D. So as I always mentioned to you, first you try to simplify this, then extract the conclusion, and after that go to the choices and see which of these choices best fit the conclusion that you have got. So let me just consider negation of P conjunction of P disjunction Q. Now this is a distributive property. Now we can apply distributive property here. So that would give us negation of P with the conjunction of P with P followed by disjunction, and then we are applying negation of P conjunction Q. Now this is actually P intersecting with its complement. What would the outcome be? Clearly it will be empty. And then you are performing a union with negation of P conjunction Q. So union of any set with empty set would give us the same set. So this is going to be negation of P conjunction Q. But we are expected to obtain the negation of the statement. So let me write down the solution here. Therefore the negation of P conjunction Q is equal to negation of negation P. When the negation hits conjunction, it becomes disjunction followed by negation of Q. So this is going to be P disjunction negation of Q. So if you were to see the correct answer, the right answer for this question is going to be choice D, and that is a good place for us to stop and move on to the next question. Let's do this question, students. We've been asked to find the negation of the Boolean expression P disjunction of negation of P conjunction Q, and we have four choices. So let's first consider the given Boolean expression P disjunction of negation of P conjunction Q. Now this is the equivalent of the distributive formulae which we have studied previously. So I would be distributing P disjunction throughout. that would give me P disjunction of negation of P conjunction of P disjunction Q. Now P union its complement would give us a tautology. That's going to be a universal set. Now this is actually having an intersection with P disjunction Q. Now what happens, you perform an intersection with the universal set, you get back the same set. So this is going to be P disjunction Q. Now we are expected to obtain the negation of this Boolean expression. So therefore, let me give the solution here. Negation of P disjunction Q is equal to negation of P when disjunction its, I should say when negation its disjunction, it becomes conjunction, and negation is hitting Q now. So this is what we have got. If we were to look at to the choices given, clearly the choice B is the right choice for this question. Let's do this question, students. We are expected to find the negation of negation S, disjunction of negation of R, conjunction of S. So we have to obtain the negation of this statement. So foremost, what we will do is we will consider negation of S, disjunction of negation R, conjunction S. Now I'm going to distribute negation of S throughout, so that would give me negation of S, disjunction negation of R, conjunction negation of S, disjunction S. And this is the universal set. This is a tautology. So you have an intersection with the tautology, which is going to give us, let me write this down, negation of S, disjunction negation of R. Now intersection with the tautology would give us the set back. So this is going to be negation of S, disjunction negation of R. And so this is the outcome we have got. Let me write that down. Negation of S, disjunction negation of R. Now we are expected to obtain the negation of this entire statement. So let me write this statement down. Negation of S, disjunction negation of R. Now taking the negation, in other words distributing the negation throughout, this would give me negation of negation S. When negation is disjunction, it becomes conjunction, and negation of negation R. So negation of negation R. This is equal to negation of negation S is going to be S. I have a conjunction here. Negation of negation R is going to give me R. So the right solution for this question is choice D. Now we would be going on to apply the truth table for questions henceforth. So whatever questions we are encountering henceforth, the truth table would be used as a tool. So we are expected to find the equivalent to this Boolean expression. So let me write the question down. Find the equivalent expression given that P conditional Q conjunction of Q conditional negation of P. So this is the expression that is given. So we will obtain the truth table and then make the decision. So for that I would like to draw the truth table. I'm drawing it to render some neatness in the work. So that it will be pleasing to the eyes. So I need to have a P value, a Q value, then the negation for P, and I need to have a P conditional Q, and then Q conditional negation. Right, this space is used for conclusion. So we are expected to find the correct choice. We have been given A, B, C, D. So foremost, let us just write the truth table. This is P, Q, and the negation of P, P conditional Q, and Q conditional negation of P. Now this is the conclusion, right? So the conclusion is going to be P conditional Q conjunction with Q conditional negation of P. So we have to have a conjunction between these two. So I'm going to take the values of T, T, F, F, and then T, F, T, F. Negation of P is going to be, negation of T is F, F, T, and T. Now P conditional Q, as I already mentioned to you, what we're going to do is we're going to use this law. T going to F will always give us F. So look for that. T going to F. So in this case, T going to F will always give us F. So T is going to F. The rest of them is going to be T, T, T. Next, Q conditional negation of P. So we need to look for T going to F. T going to F will give me F. The rest of the decisions is going to be T, T, and now we need to obtain P conditional Q and Q conditional negation of P. Now it is imperative to understand whenever we see this operator, this is equivalent to product operation, and whenever we see a T, it is taken to be as 1. Whenever we see F, it's taken to be as 0. So 1 multiplied with 0, what do you get? You get 0. That's going to be F. 0 multiplied with 1 is going to be F. 1 multiplied with 1 is going to be T. 1 multiplied with 1 is going to be T. So you get F, F, T, T. What is that equivalent over here? The only place where you can see F, F, T, T is negation of P. So the right answer is this particular Boolean expression produces as negation of P. And where is that negation of P? That is present in choice D. So that's the right solution for this question. Now, this is just a side note. What I wish to do is I would like to prove this P conditional Q, or I would say I can conclude the outcome of the Boolean expression without using the truth table. So this is how it is done. This is what we have been given, right? Now if I were to take this as A and B, you can either use it in the way taking this as A and this as B, but what I would do is I would like to utilize the property which we have learned. We know that if P conditional Q is given, then this is nothing but negation of P conjunction Q. This is the equivalent formula. I should say disjunction, right? P conditional Q is equal to negation of P disjunction Q. So if we were to take this as 1, therefore 1 can be rewritten as, in place of P conditional Q, I'm going to write this as negation of P disjunction Q followed by conjunction. I'm going to apply the same formula. P conditional Q is equal to negation of P disjunction Q to this Q conditional negation of P. So if I were to apply, then I will get negation of Q disjunction negation of P. Now A union B is same as B union A. Now why am I writing this? So that I can flip this. So I'm using this side. If I were to flip this, then this is going to be negation of P disjunction Q followed by a conjunction of negation of P disjunction negation of Q. This is what I've got. So now what I wish to do is I would like to take negation of P out, and you got the disjunction operator. Open the parenthesis. So this is going to be Q followed by the conjunction operator, and that has to be followed with negation of Q. So this is the distributive property which we've been using quite often. Now Q intersection its complement will give us phi. That's nothing but empty set. Now this is nothing but negation of P union with phi will give us negation of P, which is what we have obtained using the truth table. So without even the truth table, it is possible to obtain the outcome for this particular question. Let's do this question, students. We've been asked to find the equivalent to the given expression to the following proposition. We've been given P conditional negation of P conjunction negation of Q. So what I'm going to do, I would be utilizing the truth table to obtain the solution. So let me draw the truth table. So this is for P, for Q, and negation. In fact, I will have to take the negation of Q first, and then this is going to be P conjunction negation of Q, and then this is going to be negation of this P conjunction negation of Q, and then finally the conclusion. So this is quite a bit to have, but we are going to get through this. Okay, so this is my P, this is my Q, this is negation of Q, this is my P conjunction negation of Q, this is negation of P conjunction negation of Q, this is P conditional negation of P conjunction negation of Q. So let me take the values as T, T, F, F, T, F, T, F. Negation of Q is going to be F, T, F, T. This is P conjunction negation of Q. So as I have already mentioned that we will be taking the conjunction to be the multiplication operator, and T to be as 1, F to be as 0. So T 1 multiplied with 0 will give me 0, 1 multiplied with 1 would give me 1, 0 multiplied with 0 will give me 0, 0 multiplied with 1 would give me 0. Now we need to take the negation of this. So negation of F is T, negation of t is f, negation of f is t, negation of f is t. Now we need to obtain p conditional of this statement, negation of p conjunction negation q. So we will use this law, t going to f is taken to be as f. So t going to t is going to be t, t going to f is taken to be as f, f going to t is t, f going to t is t. So what have we got here? T, f, t, t. Can you see that? T, t, f, f, t, 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 t. So what is the outcome for this particular Boolean proposition? So clearly this is going to be the outcome, negation of p conjunction negation of q, but this doesn't feature in the choice. So if you have to distribute this negation all throughout, this is going to be negation of p. When the negation hits conjunction, it will become disjunction, and you have negation of negation q. This is equal to negation of p disjunction, negation of negation q is going to be q, and the correct choice is going to be option B for this question. Now I'm going to show you the other technique by which we wouldn't be utilizing the truth table. So we are given this proposition, p conditional of negation of p conjunction negation of q. Now we know this formula, p conditional q is equal to negation of p disjunction q. If I were to apply this formula, then we could rewrite this to be as negation of p followed by the disjunction and then the quantity over here. So there's going to be negation of p conjunction negation of q. Now this is equal to negation of p disjunction. You can distribute the negation, so that's going to be negation of p followed by negation hitting the conjunction will convert it into a disjunction, and then you have negation of negation q. So this is equal to negation of p v negation of p v negation of negation q. That's going to give me q. So this is what we have got. Now if you were to club these two together, what is this? Negation of p union negation of p. That's going to be just negation of p followed by union of q, and this is the choice that is featured in B. Let's do this question, students. The question is given as follows. Let P, Q, R be three statements such that the truth values of P conjunction Q conditional negation of Q disjunction R is false. Now they are asking us what should the truth values of P, Q and R be so that we can get a false statement here. So this is the requirement. The outcome is already been given here. Now let us just consider P conjunction Q. Now my question is, when would the right hand side be F? I've already given you a tip that T going to F will produce us F. This tip I've already mentioned. So that would mean P conjunction Q should be T. When would this be possible? I mentioned to you that we would always take the conjunction operator as product, and for P conjunction Q to have a T value, that is possible because of the fact that the conjunction is taken to be as product, both T, in other words, both P should be T and Q should be T, because T multiplied with T would give me T. 1 multiplied with 1 would give me 1. And I need a 1 here. So definitely P should be T and Q should be T. Now for R, if you were to take the negation of Q, in this case negation of T is going to be F. Now this is nothing but the OR operator, and it is imperative that this produces the outcome F. So when would that be possible? That is only possible when R is equal to F. F or F would give me an F. If I were to have a T there, then outcome is going to be T, which would contradict the given question. So the right choice for PQR would be TTF. And with regard to the selections, the correct choice would be choice D. Let's do this question, students. We've been given that if P conditional P conjunction negation of Q is false, then we are expected to find the truth values of P and the truth values of Q. Now this is possible only if P is T leading on to F, which would produce an F, because this is the formula that I have already given to you. So P is T, but the question comes, what should the value of P conjunction negation of Q be? Now clearly this should give us F. Now when would that be possible? Because this is a product operator. That is a tip I have given you. So the outcome should be an F. So when would that be possible? Because P is already a T here. So T times F would give us an F. So for negation of Q to be an F, Q should be equal to T. So this in turn would mean my P is equal to T and my Q is equal to T. So this is the correct solution. So thereby, when it comes to the options, C is the correct option for this particular question. Students, this is the next type of questions that you might be posed with. This is called tautology. Now, the meaning of tautology is clearly self-explanatory. In this case, we have to obtain truth values of just T at the last column. In other words, the result for any Boolean expression or a proposition should result in a truth value as T. Then we can call it to be a tautology. So that is the basic understanding. Now we've been given to choose the tautology. So let me write the question. The statement among the following that is a tautology is, so we have four choices. Choice 1, A conjunction of A disjunction B. Number 2, B conditional of A conjunction of A conditional B. And then 3 is A conjunction of A conjunction B. And the last one is A conjunction of A conditional B. This entire thing is implied to be. Now instead of PQ, we've been given AB. So this is a simple question. You can either use the truth table or the set theory techniques to extract and find out which is leading to tautology. Now the rule of thumb is, whenever you have an implied sign like this, the possibility of these two resulting in a tautology is high. Have that in mind. So that's the technique that you need to know. Whenever there is an implied sign, then those choices have a high probability. So you can start off with those choices. Now, if you are drawing the truth table, in one go, you can check all of these in one go. So let me just do that. So I'm going to take A here, B. So I would check this first, and then I would check this first, and automatically these two can also be checked. So let me take A, B, and then I will check A conditional B, and then I will obtain A conjunction of A conditional B. Then I will obtain this A conjunction of A conditional B. This entire thing is implied with B. So this is for the choice 4, or sometimes they will say choice A, choice B, choice C, and choice D. So this is for the final choice. Now clearly you can see that instead of going from left to right, over here it's the other way. So this is actually B conditional A conjunction of A conditional B, right? Now we can obtain the truth values for all of these, and let me just draw the table. Okay, so this is the table we have. I could have fit in the other things also, but it's still okay. If the questions are being asked, there is a slight rearrangement here. In your school examination, it's always better to draw tables like this, neatly, okay? Okay, so I'm going to take the values as T, T, F, and F. So this is going to be T, F, T, F. Now we are going to use this technique. T going to F will give me F. So this is A conditional B, so T going to F will give me F. The rest of the outcomes is going to be T, T, T. Next is A conjunction of A conditional B. So you are actually performing the product operation. So I mentioned to you, we take this as the product operator, and T as 1 and F as 0. So this is going to be T multiplied with T. In other words, 1 multiplied with 1 is going to be 1. This is 0, this is 0, this is 0. So now we are going to have a conjunction of A conditional B conditional B. So we will use this law. So this is the leading column. So this is actually implied with B. So if this, then B, right? So we are using this technique, T going to F. So look for T going to F anywhere. Now apparently, we will have to connect t going to f. Is there any t going to f? Apparently there isn't any t going to f. If there is a t going to f, then we would have to place a f here. So all of these things is tautology, right? Now conversely, or on the contrary, instead of going from year to year, we will have to have the B column to be the leading column. So we will have to check if t going to f is there anyway. We got f going to t, t going to f. Apparently we do not have t going to f. So if you have to look for t going to f, you can clearly see that t going to t, no. F going to f, no. T going to f. This is going to be f here, right? And the rest of the quantities is going to be t, t, t. So clearly the choice D, or if they represent it as 4, this would be the tautology. The rest of the cases you can simply outrightly rule them out, for the simple fact that we have a table, and if you are willing to extract, if you are not sure of, I can literally show you the other things also. I will just place a divider here so that I can fuse in the other things also. So I'm going to show you that this is not a tautology. So let me have a disjunction B here, and this is going to be a conjunction of a disjunction B, right? So this is going to be A or B. So B is treated as plus, and let me show you that. So T, T, this is going to be T, T or F. 1 added with 0 will give me 1. 0 added with 1 would give me 1. 0 added with 0 would give me 0. Now we are apt to perform a conjunction between these two. As I mentioned to you, conjunction is taken to be as product. So 1 multiplied with 1 is 1, 1 multiplied with 1 is 1, 0 multiplied with 1 is 0, 0 multiplied with 0 is 0. So clearly this is ruled out, and the same with this. You can try it out, and definitely this will also be ruled out. So the only choice will remain here is D.